Okay, hello everyone. It's an enormous pleasure to introduce Caroline. I've known Caroline for quite a long time. We met, I think, at the Child Language Seminar in Sheffield back in 1998. And either at that conference or at another conference shortly afterwards, Caroline just gave absolutely brilliant talk. It was based on her PhD, which was a critique of the then current generative account of language development. And it was very, very interesting and very, very funny as well. And a very nice lesson in how to do hypothesis testing using corpora, and also how not to do hypothesis testing doing corpora. Anyway, that was incredibly cool. And I knew from that moment on that she was someone to watch. And that prediction was definitely true, because today she is a very important person and also a very busy person. So she's the director of the language development department at the Max Planck in Nijmegen. She's also a professor of first language acquisition at Radboud University. She's a professor of developmental psychology at the University of Liverpool. That's enough for 3 people. But on top of that, she's co-director of the ESOC International Center for Language and Communication, which is this absolutely massive project involving the universities of Manchester, Liverpool, and Lancaster. As you probably gathered from all this, her main interest is language acquisition, how children communicate with language, how children learn to use language, but she's also interested in the brain processes supporting these processes, and also cross-linguistic, cultural, and individual variation. And she approaches this using a variety of different methods, and it's all very exciting. I don't think I need to say anything more. I think you are much more interested in hearing what Caroline has got to say. So over to you, Caroline.
Thank you very much, Ava. Now I am under a lot of pressure to be funny and interesting. I am going to share my screen to begin with. And I'm hoping that if you can't see it, you will shout me in the comments. I want to start, though, obviously, by saying thank you to the organisers. This really has been an incredible conference. I get the feeling that the organisers are very much like swans swimming along a lake on the top of the water. They seem to be resolving, on the top of the water, they sort of seem to be resolving all the technical hitches and guiding us very smoothly through the sessions. But I suspect that underneath the water, they're really frantically paddling and probably getting very little sleep. But as far as I can see, this conference has gone swimmingly. I am definitely enjoying it, and I am learning a huge amount of information. Okay, so my talk, it's going to be in 2 parts. The first part, I'm going to talk about the challenge for a language acquisition researcher, a challenge that I've been working on for the last 20 years, or actually longer, since I've known Ava. And I think the challenge is this: what is the language acquisition device? Now, serendipitously, at the end of Gabriella's talk, plenary talk yesterday, someone asked, well, what is the core language network? And I'm going to tell you what I think it is in this talk. Then in part 2, I'm going to cover some of the first evidence coming out of the Language 0 to 5 project, which is yielding what I think are some nice insights into how children build a language. And I'll cover 3 insights in summary, and then I'll explore the 4th in more detail to give you more of a flavour of the work. A really important caveat is that we are just at the very beginning of exploring these data. We have 3 papers published and about, I don't know, 1 million to go. So, and this is actually the first kind of big talk I'm giving on this topic to a large audience. So your comments and your ideas and your questions are very welcome, especially comments like, have you thought about so-and-so, or, I'm not sure that quite makes sense, Caroline. I really very much welcome those, those sorts of comments. So, okay, but let's start with the challenge. So For this, I actually want to take you all the way back to what Chomsky said originally when he spoke about a language acquisition device. And given this audience, I suspect that there is lots of groaning now going on across the world when I mention Chomsky, but I do want to go all the way back to what he said in 1959, because I think it's an important starting point really for some of this work. So this is a statement from his very famous review of Skinner's behaviorist theory, which suggested that all that was needed for language acquisition were behaviorist principles of learning. And Chomsky actually agreed with Skinner that reinforcement, casual observation, and natural inquisitiveness are important factors in the language acquisition process. But he argued that we also need to build in the remarkable capacity of the child to generalize, hypothesize, and process information in a variety of very special and apparently highly complex ways, which in 1959 they couldn't yet describe or begin to understand. Now, interestingly, he also says that these could be largely innate or may develop through some sort of learning or through maturation of the nervous system. So at that point, he was still sitting on the fence. But of course, later on in his own work, he devised his own theories of what the language acquisition device might contain. And as we all know, he hypothesized that the most important thing about the language acquisition device was that it contained universal grammar, a set of universal principles or rules common to all languages that are innately represented within the language acquisition mechanism in the brain. Actually, at this point, I should just say, if there's a problem with the sound at any point, please flag it up in the chat, and then maybe Eliza or Ava can let me know, because I can't see the chat at the moment. Okay, so Chomsky put universal grammar into the LAD. Of course, this is only one view. Chomsky's is not the only linguistic theory in the world, and there have been a lot of theories about what the language system is over the years, or as I prefer to think of them, theories about what we should put in the language acquisition device. But I am going to focus just on Chomsky again for a few more minutes, because I want us to think about the question of why Chomsky and a lot of other theorists put innate universal grammar into the language acquisition device. So the reason he put universal grammar in the LAD is he could see no other way that linguistic knowledge could get there. So language acquisition clearly couldn't be explained by behaviorist learning principles, because children acquire hierarchical structure-dependent rules and abstract categories. And also, he argued that the input just doesn't provide the information necessary to learn these sorts of rules and categories. So in the realm of morphosyntax, for example, he argues that the degenerate quality and narrowly limited extent of the available data leaves very little hope that much of the structure of language can be learned by an organism initially uninformed as to its general character. However, that was a very long time ago, and since that, this is the, sorry, just to point out that most of you, I know this already, but this is the logical argument from the poverty of the stimulus. So we learn a certain kind of linguistic knowledge. There's no evidence in the input to learn this linguistic knowledge, and therefore some types of linguistic knowledge must be innately specified. But since then, we've done a lot of work on how children actually acquire language, and a lot of this work suggests that the argument from the logical problem of the poverty of the stimulus really doesn't hold. So, for example, the logical problem relies on a particular conception of the learning process, and many have argued that, or shown that different types of learners can learn structure-dependent hierarchical phrase structure. But most importantly, perhaps, the poverty of the stimulus argument is really predicated on the idea of the child as a passive learner, simply absorbing information from the environment. And this is just not how children learn. For children, learning is purposeful and active. They choose what to learn, and they seek learning opportunities out. So as Katie Toomey and Gert Westerman have said, infants are curious learners who drive their own cognitive development by imposing structure on their learning environment as they explore. In other words, children are perfectly capable of creating structured knowledge out of their experience of the world. And this creation of knowledge actually And this sort of seeking learning opportunities actually happens spontaneously, as I'm going to try and illustrate in this video of a child learning about gravity.
What's that? Oh, did you drop it by accident? Oh dear. Shall we put it back up here for you to play with? Be careful you don't drop it by accident again. Oh, whoops! Did you drop it by accident? Oh, poor you. Oh dear. Poor Flinda, he wants to play with you. I'm glad we didn't drop it again.
I don't know about you, but I can just feel the anticipation before the third time that she drops it. But what this shows really nicely, as Bruna said, that we don't need instruction to learn. Practice in discovering for oneself teaches one to acquire information in a way that makes that information more readily viable in problem solving. So we're perfectly capable of exploring and discovering and creating structure out of the world. Another pertinent point is the poverty of the stimulus argument relies on a very particular conception of the input. And a number of papers show that the input does actually contain the information we need to learn the properties of language, either because although some structures are rare, they do actually occur in sufficient quantities for learning, or because there are other structures in the input that provide indirect evidence for a child to discover the relevant property. And also remember that the environment is not just the speech signal, it is everything that the child can see, touch, hear, taste, and smell. And these are all cues that come together in a particular spatial and temporal dimensions and which provide multiple parallel channels of information that constrain the learning space. Again, I don't need to tell this audience that the environment is multimodal. So if you consider the interaction I'm going to show you and its potential for learning the word light.
Yeah, the lights. Oh, that's the light too, yes. Yes.
So think about all the cues that are present in this video to aid learning. The word light occurs twice, straight after the child focuses her attention on a light. So we have spatial and temporal contingency. And this allows the child to narrow down the likely referent. Plus the fact that the word is applied in two different contexts, it refers to two different objects, facilitates generalization. The word doesn't just apply to the candle, it applies to multiple kinds of lights. We all know it's very important to note that the learning environments can come in all sorts of shapes and sizes across the world, but I want to point out that they are still effective learning environments. So in many cultures, the Western style teaching-based parenting style, including the characteristic child-directed speech that was produced by the mother in the last video, this kind of style doesn't exist. But just because cultures differ in how they treat children doesn't mean they aren't providing an effective learning environment. So as Rogoff says in her wonderful book that describes child development across many cultures across the world, she says, infants' efforts to learn are accompanied by biological and cultural features of caregiver-child relationships and cultural practices that encourage involvement. Whether or not they regard themselves as explicitly teaching young children, caregivers do routinely model mature performance during joint endeavours. They adjust their interactions and they structure children's environments and activities in ways that support local forms of learning. So to sum up so far, Chomsky put universal grammar into the LAD because he couldn't see any other way it could get there. But we now know a lot more about acquisition across the world, about how children approach the learning process, and about what cues are available in the multimodal environment. So now many of us take a very different view of the language acquisition process and about what we need to put in the language acquisition device. And nowadays, many of us think this. The human brain does not simply acquire language, it constructs it. It dynamically builds linguistic representations out of information provided by a multimodal environment, at each step building on and maybe actively reorganizing knowledge that's already stored in the brain. These representations are abstract, they're partial, they're imperfect, and they're of very different kinds. They're phoneme categories, concept labels, and combinatorial rules. However, all linguistic representations of all kinds are built using the same toolkit of socio-cognitive learning and processing mechanisms. Such learning mechanisms are not blank slates, but are innately constrained to seek out and generalize across some types of information rather than others. And on this view, what is in the language acquisition device is the toolkit of socio-cognitive learning and processing mechanisms that build linguistic representations. So what is in the LAD is not linguistic knowledge itself, but a toolkit of mechanisms that allow us to extract information out of the environment, impose structure on it, and learn abstract representation. But this is rather a vague statement. What kind of mechanisms do we actually need? So first, we have to build in mechanisms that allow us to interpret and process incoming information from the multimodal environment. And actually, we already know quite a lot about cognitive development and are about what kinds of skills and abilities are necessary for this task. So we know that we need to build in a basic perceptual ability to perceive low-level structure in the world. So for example, the ability to perceive figure versus ground, or speech versus non-speech, or recognize faces, for example. We also need to build in mechanisms that allow us to acquire higher order cognitive or conceptual understanding. And we need this to meaningfully interpret events in the world and the role of objects in these events. So we need to be able to distinguish cause and effect, to distinguish between one and many, and we need to be able to develop a basic understanding of naive physics, which is what you saw the little girl doing earlier, discovering that a dropped object always falls straight down. We also need mechanisms that allow us to interpret others' actions, so social mechanisms, and we need social cognitive abilities that allow us to interpret other people's intentions, and especially their referential intentions, which is so crucial to realize that speech and sign language has meaning. And then finally, we need metacognitive abilities that allow us to selectively attend to and integrate information. So cognitive integration, planning, and focusing attention. So as well as this, we need to build in mechanisms that allow us to encode, store, and retrieve information in long-term memory. And I actually think the language acquisition community has been a little bit negligent here, because we have pretty much ignored the literature on the development of memory in children. And I think we need to inform ourselves a little bit better about exactly how children learn. And then we need to build in mechanisms that allow us to extract patterns or regularities from the incoming environment. And in a very recent position statement, we've argued very strongly that this should be a frequency-sensitive distributional learning mechanism that extracts patterns on a variety of levels, from segmenting words to extracting morphological markers to building non-adjacent dependencies. And then we need to build in mechanisms that allow us to build categories of information out of these patterns or regularities. And we need to be able to build hierarchical structure that allows us to link form to meaning, to link form to form, and to link meaning to meaning. So we need mechanisms that generalize across instances to build abstract representations. So this is what we have to build into the language acquisition device. Is this the core language network? Well, not in the traditional sense. None of these are encapsulated language mechanisms. They're all broad socio-cognitive learning mechanisms that are used to process and learn other types of information as well as language. So as far as I'm concerned, Chomsky's language faculty narrow might actually be completely empty. But what is also important for us as cognitive linguists or constructivist acquisition researchers is to acknowledge that none of these mechanisms are blank slates. They are all innately constrained to seek out and to generalize across some types of information more than others. So I'm actually not going to take a stance on what these innate constraints are. There must be some innate low-level perceptual constraints, but whether we're also born with some higher order cognitive or language-specific constraints, I don't know. I have opinions. I'm not going to discuss them here. I am happy to address what I think is the constraints are in the Q&A perhaps. But my take-home message is there must be constraints. As Stan de Haan says, pure learning in the absence of any innate constraint simply doesn't exist. The learning algorithm contains, in one way or another, a set of assumptions about the domain to be learned. So to conclude part one, what I would like to put in the LAD is not universal grammar or innate linguistic knowledge, but a toolkit of mechanisms, learning and processing mechanisms that build linguistic representations. And I realize I am not saying anything new. Most, if not all, constructivist researchers broadly agree with this characterization. But what I do think is a pity is the fact that our field hasn't made as much progress as we would like in discovering what the mechanisms actually are and how they exploit information in different environments to build mature linguistic knowledge. And that's what I want to move on to now in part two. I am now going to move on to focusing on the data from one project, the Language 0 to 5 project, which we started back in 2014 and which was designed even earlier than that in 2012 and 2013. And this was a project that we designed to help us try and discover how the language learning mechanisms in the LAD actually work. So on the left here, you can see a beautiful schematic created by one of my postdocs, Michelle Peter. And it illustrates what the project was or is, which was a large longitudinal project with the goal of tracking individual differences in cognitive, sociocognitive, and language development across the preschool years, and using these data to develop and test actually detailed mechanistic explanations of how children build language. And we've published 3 papers from this and have many, many more still to go. But I want to focus in this talk just on 4 of the insights about how the language acquisition process might work that we've gained from working on this project. We followed children from 6 months of age to 4.5 years of age. And in total, we have about 90 children completed at least one of our data points. All the children are from British English-speaking monolingual homes. They have no medical history compromising language development. They're all from mid or high SES. And we took longitudinal measures, multiple measures of language, sociocognitive, social, motor development, and environment across the 4 years. So in the rest of the talk, I'm going to talk about 3 of these insights in summary that we gained from this data. And then the last one I'm going to go through in a little bit more detail so that you can get an idea of what the project was about. Okay, insight 1. Insight 1 is that there are some basic abilities that need to be in place before language acquisition can begin. Now, some of you may be thinking, duh, well, obviously, but actually we don't have an explicit definitive list of what cognitive abilities children have to develop first before they can even start to approach learning language. So take, for example, the ability to distinguish between cause and effect, or the ability to understand causal actions. If you want to understand any causal verb, or you want to understand any phrase with a causal meaning, like the sun melted the snowman, you have to be able to interpret cause and effect in the world to perceive it. So in one of our studies, we tested 9-month-old infants in a familiarization study where we familiarized them with videos of non-causal events and then showed them perceptually similar events that were actually causal to see whether children who are just at the cusp of learning language at about 9 months of age could actually interpret causality in the world. So we familiarized them, we showed them over and over again at non-causal launching events that looked a little bit like this. So this is seen as non-causal because of the delay between the movement of the yellow box and the green circle. So let's just see that again. We then, once we'd familiarized them to these events, we showed them very similar actions, but ones that were clearly causal. So hopefully here you can see that there's no delay, or hopefully there's no delay on your screen. So it looks like the yellow box is launching the green circle to the right. And what we found was that our 9-month-old language 0 to 5 babies looked at the novel causal event longer after being familiarized with a non-causal event. So that's what you can see briefly in this graph here. The graph in the middle shows looking times to the novel causal event, which the average you can see from the grey boxes is slightly higher, which in other words, that is significantly higher than their looking times to the familiar non-causal event. Now, they didn't look longer at a novel non-causal event, which suggests that they are responding to the property of causality in the perception, in the action, rather than novelty per se. So our babies at 9 months of age, just about when they are starting to learn a language, are able to perceive this very important property of causality in the world. But interestingly, there was no correlation with vocabulary development. So the children's ability to perceive causality didn't actually contribute to individual differences in vocabulary development. So what this table shows very briefly are correlation coefficients between the infants' looking times at the causal and non-causal events. So how much they responded to the switch from non-causal to causal events in their looking time, and the relationship between that and their vocabulary acquisition at 9, 11, 12, 15, 16, and 18 months of age. And none of these correlations are large or significant, which suggests that although the children can distinguish between causal and non-causal actions, which is not surprising because this is a skill that must be there for language acquisition, actually the individual differences between the children didn't influence the trajectory of vocabulary growth. But I think it's basically because by the time they're 9 months of age, all the kids are good enough in order to be able to learn about causal events, about how to apply language to causal events. So that was one insight. A second insight I want to talk about is that some of the abilities that we think should be in place for language do predict individual differences, but not necessarily in the way that we expected. So a warning here, this is really preliminary data, so please don't cite it. We've done a first pass analysis, but we do need to go through it all, add some more kids and check our codes are correct. So in this study, we were looking at the effect of pre-linguistic non-verbal communicative gestures on children's language development. Now, there's a strong, robust relationship in the literature between children's gestural ability, so how good children are at using gestures, and their later language development, their later vocabulary development. And one hypothesis about why this might be is that gestures are facilitative of later language development in sort of communication. So children who gesture, the children who gesture a lot elicit a lot more language from their caregivers in that first year of life, because caregivers are responding to the gestures, and this then helps them build their vocabulary because they're hearing a lot more language in response to their gestures. So we tested this hypothesis by taking two measures. Firstly, we recorded the frequency with which infants used communicative gestures in a task that was designed to elicit those gestures. So you can see a picture of this here. We had these boards up around the room and the children had to, and their parents wandered around. And then we also recorded, so that records the frequency with which infants used gestures. And then we recorded the number of different gestures that they knew and that they could produce using the UK Communicative Development Inventory, the UK CDI. And this is simply a checklist where parents tick off the words and gestures their children know and use. CDIs are very famous. They're very reliable, standardized measures of recording language and gesture use in very young children. So if our hypothesis is correct, we should see a strong relationship between gesture frequency and later language use. So we should see that children who gesture a lot and thus elicit more language from their caregivers in response to the gestures, those children should have larger vocabularies later in infancy. But actually, we didn't find support for this hypothesis. Gesture frequency at 11 months did not robustly predict vocabulary comprehension, as you can see from the top graph here. Instead, it was the number of different gestures that children are able to use and understand that predicted their later vocabulary comprehension. Now, I said this is preliminary data, so the caveat is that we could have done something wrong in our analysis, and we'll discover this when we check the code. But if the relationship holds, it suggests that there are robust, stable individual differences in children's communicative ability as a whole, both verbal and non-verbal, that are apparent from their very first gestures and then transfer into their early word learning. The third insight is one that I think really hasn't been given enough attention in the literature, and it's the role of the child's existing knowledge in the learning process. And what we've learned here is that some of the apparently intrinsic differences in ability are actually emergent properties of the acquisition of linguistic knowledge. So to illustrate this, I'll talk very briefly about a study we did on lexical processing speed at 19 months of age. Now, lexical processing speed refers to how quickly children respond to a familiar word, and it's tested by seeing how quickly they look at the referent of that word. So you play them a phrase like, "Where's the baby?" in beautiful Western child-directed speech, so "Where's the baby?" And then you use an eye tracker to measure how quickly they move their eyes to look at the baby after hearing the word. So let's see if this example works.
Where's the baby? Can you see it?
And this is what this little child here on the right can see. And as soon as she hears "Where's the baby?" she looks at the baby here on the left.
Where's the baby?
Do you want to run that again? Okay. So here are the results. What we found when we tested children at 19 months of age was that their processing speed, so how quickly they responded to familiar words, actually predicted their vocabulary growth, their vocabulary size at 19 months, and predicted their vocabulary growth over the next year or so, although this relationship did change over time. But really interestingly, we repeated the processing speed study at 25 and at 31 months, and there was no relationship with vocabulary at all. So the relationship between processing speed and vocabulary only held at 19 months of age. Not to go into details, but we explored why this might be. And we discovered that the most plausible explanation is that it wasn't that faster processors were processing words faster overall, but they actually had stronger representations of familiar words in their lexicon, and they could retrieve these familiar words more quickly. So in other words, it's not that some babies or some 19-month-olds are intrinsically faster processors of language. It's simply that some children have a stronger representation of familiar words, and these children also had faster vocabulary growth. So we're now exploring a number of reasons why some children develop stronger representations of familiar words and why that then affects the acquisition of new vocabulary. And we're exploring this in new experimental work and in computational modeling work, but I'm not going to talk about that today. What I am going to do is move on to the last insight that I want to talk about, which is one I'm going to discuss in a little bit more detail. And partly because it's the insight that I'm most excited about. And it's the insight that we actually develop domain specificity over time, that some domain general learning and processing mechanisms become specialized as the child accumulates more knowledge in each domain. So when we talk about domain specificity or domain generality in cognitive science, we tend to assume that the mechanisms are either domain specific, so they work on a particular domain like language, or are domain general, that they apply across domains and can be used in a number of different cognitive tasks. But what might actually be going on is that we start out with domain general learning mechanisms that become specialized for language, for example, as the child accumulates more knowledge in the language domain. And I'm going to illustrate why I think this might be with two of our studies on statistical learning and then a brief look at another study in the literature. Okay, so statistical learning is the, apparently, domain general ability to extract statistical regularities from the environment and learn from them. And most relevant for us, we have a lot of evidence that infants can use statistical learning to segment words from the speech stream. And in this example, they can use transitional probabilities between adjoining syllables to segment words out of the speech. In fact, infants and adults can even track non-adjacent dependencies and use these to segment speech. So they can segment speech by tracking the probability that two syllables tend to occur together, even if there's intervening material between them. And a number of authors have shown this using artificial language experiments with both adults and with children. So what you do in these studies is you create an artificial language in which two syllables always occur together, separated by one intervening syllable. So here we have ba and so, which always occur together, but they could be separated in the speech stream by mu or ga. So you could have ba, mu, so, or ba, ga, so. And you familiarize infants or adults to these dependencies to these syllables in continuous speech with no other cues. So it's an artificially generated speech, so it sounds something like ba, mu, so, li, ga, fe, li, mu, fe, ba, ga, so. And we did this with infants for about 10 minutes, but with adults, adults can extract the regularities after only sort of 2 or 3 minutes. So you familiarize them with this, and then you test whether they can distinguish between words and part words. And importantly, the only difference between words and part words is their consistency with the non-adjacent dependencies in the training speech stream. So both words, so ba, so, and part words, so here mu, ba, have occurred in the speech stream together, but only ba, so have occurred consistently together with only one intervening item. Evidence of statistical learning, of being able to segment using non-adjacent dependencies, is shown by an ability to distinguish familiar and words and novel part words. And you can either get, in infant studies, you can either get a novelty effect, where they look longer at the unfamiliar part words, or you can get a familiarity effect where they look longer at the familiar words and the unfamiliar part words. But either way, it's evidence that they are treating the two different kinds of stimuli differently, and therefore they've learned something about the relationship between the syllables. So in our study, we tested whether the language 0 to 5 babies could use non-adjacent dependencies to segment the speech at 17 months of age. And we also tested to see whether individual differences in their segmentation ability predicted their vocabulary size and their vocabulary growth. So we had 71 of our 90 infant sample yielded usable data in this task, and we gave them the task at 17 months for a number of reasons, which I won't go into. And we basically gave them the task that I have just outlined to you. We familiarized them to speech with non-adjacent dependencies and then tested to see whether they could distinguish between the familiarized words and the novel part words. And importantly, we calculated a Cohen's D difference score, which is the mean looking time to part words minus the looking time to words, divided by the pooled standard deviation of looking time across trials. And because this basically controls for individual differences in overall attentiveness. And then we also had vocabulary measures. We used the good old CDIs to get measures of the children's receptive vocabulary, so how many words they understand, and their expressive vocabulary, how many words they produce at 16 months, or 16 to 17 months. We have sort of data points that cross 16 to 17 months. And then we also looked at their later vocabulary at 19, 21, 24, 25, 27, and 30 months of age, using the parent report CDIs. So to answer our first question, do infants use non-adjacent dependencies to segment the speech? The answer was yes. We had a robust familiarity effect that held even when you controlled for trial order, because you get a bigger effect at the beginning. Children overall looked longer to the familiar than the unfamiliar words, which suggests that they had segmented the words from the speech stream using the non-adjacent dependencies relationship. And the answer to our second question, does an infant's ability to segment predict vocabulary growth, was also yes. So what you see here are scatter plots, the relationship between segmentation ability, so looking time differences, and concurrent vocabulary at 17 months, both with receptive and expressive vocabulary. So this is just when the babies are 17 months. And what you can see on the right here is the relationship over time. So the red line shows you the children who scored above the segmentation median score. The blue line indicates the children who score below the segmentation median score at 19 months. The grey lines represent individual children. And you have, on the graph at the top, we have receptive vocabulary on the y-axis and age across the x-axis. And then the graph at the bottom, expressive vocabulary is on the y-axis. And what you can see is across the board, so for a whole year, between 19 and 30 months of age, the good segmenters, the kids who were good at segmenting at 19 months had better vocabulary than the children who were less good at segmenting at 19 months of age. And although the relationship did change over age, as some of you might have spotted, and again, for details, you can see the paper by Rebecca Frost et al. In cognitive psychology. So to summarize these results, infants were able to draw on non-adjacent dependencies to segment speech at 17 months, and we had a relationship between segmentation ability and vocabulary acquisition, which maintained for the next year. They didn't grow their vocabulary faster, they just maintained the advantage, but that could be due to ceiling effects on our vocabulary measures. Okay, so is this evidence that children's language ability is affected by a domain general statistical learning mechanism? Statistical learning has traditionally been seen as a domain general mechanism, but it may not be. It could be that we have lots of different domain specific statistical learning mechanisms. And on this view, an individual child's ability in statistical learning would depend on the domain. So a child could actually be really good at visual statistical learning, but bad at auditory statistical learning. In our study 1, we only looked at statistical learning in the speech domain because our stimuli are speech syllables. So we don't know if we captured a relationship between vocabulary and a domain general statistical learning ability, or if we've captured a relationship between vocabulary and a speech specific statistical learning ability. So to do that, we need to look at statistical learning in another domain, a visual domain maybe, and see if that also correlates with vocabulary learning. And this is what we did in study 2. In study 2, we tested whether the same infants used statistical information to extract regularities in visual stimuli. We did it at 12 months of age for a number of reasons, but again, I won't go into. And then we also tested whether infants' ability to extract regularities in visual stimuli predicted vocabulary growth after 12 months of age. Again, a caveat, this is preliminary data. We've done a first pass, but we haven't gone back and checked the code, blah, blah, blah. So it could change. I don't think it will. The effects really are quite strong, but please don't consider this gospel. Again, the same infants. This time 75 of our 90 infants yielded usable data. And as I mentioned, we did this task at the 12-month data point. In language 0 to 5, we always, because every child is precious, we can't like pilot and then run the study again, because we always try and use established procedures from the literature. So we try and replicate other people's procedures. And here we did a replication of Kirkham et al. In 2002, and this was a visual sequence learning study. So what we did is we habituated infants to sequences of shapes in which the transitional probabilities defined pairs. So the pairs were ordered following a statistically predictable pattern. And for those of you that know the literature, this is very similar to Safran's original study done in the speech domain. And the stimuli consisted of 6 colored shapes that were presented one at a time in a continuous stream with no breaks or delays between shapes. So the turquoise square was always followed by the blue cross. The yellow circle was always followed by the pink diamond. The green triangle was always followed by the red octagon. I think that's an octagon. But the transitional probabilities between pairs were only 0.33. So the blue cross was only followed by the yellow circle a third of the time. And then just as we did in the other, in the first study, we tested the children's looking time reactions to pairs. So these are familiar pairs that they've always seen one after the other, or to part pairs. So again, novel pairings that they've only seen together a third of the time, or consecutively a third of the time. And again, exactly the same kind of analysis strategy. Evidence of statistical learning is shown by an ability to distinguish between familiar pairs and novel part pairs. And again, we calculated Cohen's D difference scores to control for overall differences in attentiveness. Some of our babies pay a lot more attention to the screens than others. So our first question was, do infants use statistical information to extract regularities? And the answer here is yes. What you can see on the x-axis is mean looking time. Apologies that these are box plots. And what you can see on the y-axis, sorry, is mean looking time to familiar and to novel stimuli shown on the x-axis. And we did replicate the group effect of Kirkham et al. So the children showed a familiarity effect. They looked longer at the pairs and the part pairs. But unlike in study 1, the infant's ability to extract regularities in the visual stimuli did not predict their vocabulary growth. Now, again, these are preliminary, so they're only done correlations. Growth curve analysis is to come. But what you can see on the top line, A, B, C, and D, are the relationship between the visual sequence learning score of the babies and their vocabulary comprehension at 12, 15, 16, and 18 months, going across from left to right. And exactly the same, but here there's a relationship between visual sequence learning ability and production, vocabulary production at the 4 ages. Only one of these correlations reaches significance. That is relationship between visual sequence learning and children's comprehension at 18 months of age. I think it's a false positive, or at least just evidence of a very weak relationship. So to summarize, unlike in study 1, we did find a group effect. The infants did use transitional probabilities to learn the regularities, but children who showed a bigger preference for the novel stimuli did not have bigger concurrent vocabularies or bigger vocabularies later in development. Okay, so how do we explain the results of these 2 studies together? There are at least 3 explanations. One is that there are methodological problems with the visual sequence learning task, but remember we did get group effects, so we replicated the basic effect found by Kirkham. Our infants did learn the statistical regularities in the visual stimuli. So there's no reason to think that learning isn't happening here. The second explanation is the obvious one, that we actually don't have domain general statistical learning abilities, that we have at least 2 domain specific abilities, one in the visual domain, which doesn't predict language, and one in the speech or maybe the auditory domain, which does predict language. If that's true, it raises an interesting question about what happens with sign language. And I think the answer is it's what we'll see. But the third hypothesis is actually the one that I prefer, and I'm going to explain why in 1 second. And this is that we start out with an initially domain general ability that becomes tuned to language as the child learns language. So we have, so what we're doing is we're developing a domain-specific statistical learning ability. And the reason to explain why I favour this explanation, I turn finally and very briefly to evidence not collected by the Language 0 to 5 team, but by my colleague Evan Kidd in a parallel project in Australia. And this is evidence from the literature from segmentation tasks with young infants of 9 months of age using EEG measures. So Evan's study, plus a number of other studies actually, have shown that infants' brain responses to the task of segmenting speech changes with the onset of language. So in these tasks, infants are again familiarized with speech stimuli or played speech stimuli, and then they're tested on their ability to extract words from the speech stream by measuring ERP responses to familiar words that have occurred in the speech stream like eagle and unfamiliar words. And what a lot of these studies seem to be finding, although I think that we need a lot more replication to be absolutely clear, but what a lot of these studies seem to be finding is that children have different responses depending on how much language they know, either concurrently or subsequently. So here I'm showing evidence from Evan Kidd et al., but there are results from other studies that show similar effects. These graphs show ERP responses to familiar and non-familiar stimuli in the 250 to 500 millisecond time window after the onset of the stimulus. And what was found in this study was that the group of 9-month-olds divided into 3 different groups. First of all, you can see on the left positive responders. These are children who had a positive response, ERP response, to familiar words that occurred in the familiar screen. And apologies if you can't see colour, but by the familiar response, I am referring to the bottommost line on the graph. And you can see that this is lower than the responses to the unfamiliar stimuli in the other lines. We also had no difference responders who really didn't show a difference between familiar and unfamiliar stimuli. And both of these groups actually had a smaller vocabulary 3 months later than the negative responders who are shown on the right. Now, these are children who had a large negative response in the ERPs to familiarized items. And again, if you can't see color, what the negative response is the one on the top, is the line on the top, which shows that the children's response, and the fact that the 3 lines again are separate, are showing that the children are responding differently to the familiar and the unfamiliar stimuli. So what this literature seems to show is that the positive and the no different responders have a smaller concurrent and or subsequent vocabulary than negative responders. And how this has been interpreted by a lot of people in the literature is the idea that we're seeing here a shift in how infants respond to speech stimuli. And the idea is that the acquisition of a basic lexicon triggers a qualitative shift in the response to the speech stimuli from an immature positive to a mature negative response. And in these studies, the negative responders who are children who have already shifted to this new state, who've already shifted to a mature online lexical mode of processing. And I think this is the explanation that best fits all the data I've cited so far, study 1, study 2, and the EEG studies from the literature. Infants start with a domain general statistical learning ability. Good domain general ability may give children an initial head start in acquiring language, we never know, but the effects are small or not long lasting, which is why we don't see a relationship between visual sequence learning in study 2 and vocabulary acquisition. Then the acquisition of a basic lexicon triggers a transition to a mature mode of processing, and individual differences in when or how this transition occurs leads to individual differences in subsequent vocabulary growth. So I think what this means is that children who switch to a more mature lexical mode earlier are actually at an advantage in later vocabulary learning. So in a sort of snowball effect, maybe, in where the acquisition of knowledge facilitates the more rapid acquisition of new knowledge as the child ages. So that's it, really. What I've tried to argue is the LAD is not universal grammar, but a toolkit of learning and processing mechanisms that build linguistic representations. And I think that if by studying individual differences in what these mechanisms are and how they might work, can reveal some surprising insights about how the LAD must work. Important caveat here. It might reveal important insights into how language learning mechanisms work in British English. And it is actually still a moot point as to whether or not children learning different languages across different cultures actually use the same kind of suites of toolkits of language learning and processing mechanisms. But we could talk about that in the Q&A if you wanted. I think the approach that we take has some implications for classic debate, sort of what is innate, what is human specific, and obviously what is domain general versus domain specific. And I do have views about that, but I'm going to leave those for another time. So I just want to say thank you, obviously, to the huge number of people who have worked on the Language 0 to 5 project, our partners, our funders, and most importantly, the 90 children and families who gave up pretty much 5 years of their life to help us with this research. And that's me done. Thank you very much.
All right, thank you very much, Caroline. Clap, 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 clap. Lots of people are clapping electronically. Thank you very much. We've already got lots of questions coming in, so I'll sort of alternate between the Whova and chat. So the first question on Whova is, how does the absence of a relationship between gesture frequency and word learning in your study relate to Golden Meadows results that the onset of pointing predicts the onset of two-word speech?
So I think, yes, I suggest that this is preliminary data, so we have a lot more work to do on it. And I think that's right. The onset of gesture predicts the onset of speech. So there are communicative kiddies, right? Some kids are just more communicative than others from early on. And that manifests from really, really early on, right? As soon as they start communicative pointing or communicative gesturing or, holding out and give gestures, which are really early, we see individual differences that then predict their later vocabulary acquisition. So I think there are individual differences in how communicative children are. These reflect communication in all its multimodal forms, gesture and words and maybe facial expressions, who knows? The question is why, right? Is it because these children have been encouraged to communicate since birth by their caregivers? Is it intrinsic? We get communicative kiddies. That's actually a question we can answer with the data we have from Language 0 to 5, because we have a lot of input data and interactive play, which I haven't talked about. But yeah, I think it's a key question, right? Why do we see this? But yeah, I completely agree with Golden Meadow. It's the onset that shows the relationship.
Thanks. Okay, another question from Mark Ding. I'd like to hear your thoughts on the language acquisition device as a rhetorical device. For Chomsky, that made rhetorical sense because he used a very narrow sense of language, a set of sentences, and so needed a lean and mean device. Your conception of language seems a lot broader, and the set of mechanisms needed for it is much more expansive. It's if it's not more like a toolkit or a combination of sociocognitive mechanisms and skills, is a metaphor like LAD not doing you a disservice?
I don't know if it's doing me a disservice. I mean, yeah, the LAD is a metaphor. I started this talk by trying to turn the metaphor on its head, because one of the most damaging things to our field is this metaphor of language acquisition device or language faculty narrow, I think has strangled research on the role of the multimodal environment, the role of broader sociocognitive mechanisms, and really made us focus on, what is in this narrow device. So I'm trying to use it as a rhetorical device to turn the metaphor on its head. Whether or not that works is, I guess, up to the audience to decide. But I think there's no such thing as a language acquisition device, right? There is a distributed brain, cognition in the brain, which amazingly learns language in humans.
Oh, the brain is a language acquisition device.
Brain is like, yeah, that's another metaphor I could use.
Okay, another question from Hoover. On the results, individual differences in gesture frequency not predicting word learning. Could this have to do with the type of gesture? What gestures are counted here?
Absolutely could, and I think that's a really good point when we go back to coding that data to check it, because I'm a bit anal about checking data. I think it's really good to do that. I'm also really intrigued by the idea that the lack of relationship maybe because these children are more advanced in their vocabulary. So maybe by these 11-month-olds are actually not communicating with gesture, but maybe starting to communicate with us or something, you know, where I think if they're learning vocabulary earlier, it may well be that they stop using gesture earlier. So if we'd gone earlier, we could find a relationship between gesture frequency. I'm not sure. Again, we have all the data to explore these relationships and try and figure out what's going on. Colin Bannard called, I'm not sure if he was being mean or nice, but he called the Language 0 to 5 project the biggest pilot study in history. And because it basically raises a lot more questions than it answers them. So yeah, we have a lot more to do.
Okay, going back to the Zoom room, Zilkebrand has a question. It's actually, I have a very similar question. Is there a relation between visual and auditory statistical learning in infants or older children? Did I miss this? And a sort of follow-up from me, given your account, you would expect to find a stronger relationship in younger children than in older children. So is there any evidence of developmental changes in this relationship?
Not that I'm aware of, but I'm a managing director of a big research institute, so I do not read as much as I should. So if anybody does know some literature, please let me know. What I do know is that there's a lot of literature coming out on adults, which arguing for domain-specific statistical learning. So, and that's really quite convincing evidence, which has actually partly prompted my own views. I don't know, instinctively can't believe we're born with domain-specific statistical learning abilities. So I guess if there's evidence, great, I would really like to see it, to see if I'm wrong or if I'm right, but we definitely need that. And two things to do are to go younger. So to look at very young babies and then maybe track their language later. But actually the other thing, as you say, is to track statistical learning abilities throughout development, which I think is a really interesting thing to do. Thank you.
Okay. Now there's a question on Q&A, which I'm not entirely sure how to interpret, but perhaps, have you checked these mechanisms, and I'm not entirely sure what these mechanisms are, against general non-linguistic cognitive aptitudes? Can you say that they are specific to language? But this appeared at a certain point in your talk. I'm not entirely sure where, but perhaps you can make sense of it.
If we're talking about all of the, again, I think I find it hard to see how do these mechanisms, I assume this is when I wrote down all the mechanisms, I find it hard to see how they are specific to language. What I suspect they are is perceptually tuned to pay attention to particular stimuli, perceptual stimuli, which might then be really useful for language. So I have in my to read list a really nice paper which seems to see that there may be perceptual correlates of causal versus non-causal actions, which infants could be innately tuned to, right? So that, because we know that some neurons in the brain are sensitive to some kinds of perceptual information and other neurons are sensitive to others. So it could well be that we have domain specific in the sense of we respond differently to kind of different perceptual inputs which form the basis of later domain specificity. I'm not sure if that answers the question, but that would be my intuition, that if there are constraints on the mechanism, innate constraints that cause us to pay attention to or to distinguish between two different types of perceptual input, those constraints should probably be perceptual. And maybe if it's on Hoover, then maybe they could reply and I could.
Yeah. Okay. I'm just looking. So there's a lot of discussion going on, and also lots of compliments addressed to you. People love the talk. Okay, here is a question from Maria Cesario. Thank you for the wonderful talk. Do you think there are age differences in acquiring different categories such as causality, condition, and purpose?
Yes. So this is also something that, because we're not kind of embedded in the child cognition literature, we miss. All of these things that language acquisition relies on develop themselves. So causality may come in early. Actually, let's take social cognition, right? Theory of mind, which is a better example because we know more about it. We know that develops, right? So we know that children's ability to understand referential intention gets more and more sophisticated as they get older, which is bound to affect what they can pick up from the learning environment. So Annette Karmanoff-Smith kind of describes it really, really nicely. Every development that happens in your brain affects how you then perceive and process new information coming in. So every single second, your brain is responding differently to the environment. So yes, there must be changes in cognitive development that then affect language acquisition. And that actually what makes it really complicated, because we can't say, you know, this is how children respond to this input, because that differs depending on whether they're, I don't know, 1 month and 1 day old, and 1 month and 2 day olds, and 1 month and 3 day olds. So this is why I'm so keen on computational modeling, because you can never create a verbal theory that really captures all the dynamics of development across the social cognition.
Okay. Right, I'm trying to find questions because, as I said, you can have a look at this. Hang on, there was a question here and it's disappeared now. Adele suggested replacing the language acquisition device with prerequisites, Adele Goldberg, with the term prerequisites for language learning, PLL. I don't know.
So this is funny. I've had a discussion about, you know, not about the lad, but about calling it a toolkit with Steve Levinson and Evan Kidd, because Evan doesn't like the idea of toolkit because it implies something static. And there's an interesting perspective from Steve Levinson that actually arose in Elena Lieben's Nijmegen lectures a few years ago, which is that actually the toolkit could well be different for children learning different languages. So your environment, having a different cultural environment, having a different learning environment could actually kind of itself change what's in the toolkit, or change what kinds of bits of the toolkit you use to acquire language. And I think that's almost certainly absolutely true. So I'm not sure about that alternative way either of describing it, because it doesn't reflect the kind of flexibility and dynamic change in the mechanisms themselves across cultures and across development. So I am still searching for a better term, but I still kind of like turning LAD on its head. So.
I suppose with the toolkit, so you could use the toolkit to make new tools to learn language with. You could expand on that metaphor.
You could, and then you could lose some tools, right? You could leave them in the back of the shed, but we might be getting a bit silly.
Okay, I found another question from Jody Sanford. Do you think that the color form couples, which on first sight did not seem to follow a pattern, could interfere with the extraction of significance useful for comprehension or production?
Say that again, I didn't quite get that.
Do you think that the color form couples, so this was, I think, the visual statistical learning task.
Yeah.
So the color form couples, which pairs, which on first sight did not seem to follow a pattern, could interfere with the extraction of significance useful for comprehension or production?
I hadn't thought about that, but that's a nice idea. Do you mean, so I guess this is something to have a little discussion about on Hoover maybe, but I assume the question is about interfering with the finding a relationship between the visual stimuli and vocabulary, because we did find learning in that task. So they definitely did learn.
Yes, for comprehension and production. So
yeah. So I hadn't really thought about that. So why would colour interfere with the relationship? And I guess the implication is that if we use different visual stimuli, we could recover the relationship. Yes, I don't know if anybody's done that. I think that's really interesting. I have to say, intuitively find it surprising if visual sequence learning ability was always as good as auditory sequence learning ability at predicting language, because just intuitively it seems a bigger leap, right? But I think it might be interesting to look at whether there are specific features of those stimuli that interfered with or potentially, facilitated the effect. That's a nice point. Thank you.
okay, another question from Sotaro Kita. Your dependent variable is always language ability. So it's not clear if one cognitive ability, e.g. processing speed, is correlated with language ability. It is not clear if that cognitive ability is a good index of smart kids in general. Do you have a non-linguistic cognitive dependent variable?
We do. We have tested the children's general cognitive ability. Yes, we have the Bailey scores at 16 months, and then when they get older, we have various different sort of cognitive tests. So yeah, it's true that in all of the data I presented, there's always a relationship between a variable and language. But I would say that in the data I've presented, that is the hypothesis that we were testing from the literature, right? So would you still get these relationships if you included a measure of cognitive development? Maybe, I don't know. That's an interesting other question, right? Are these individual differences in these relationships that we're seeing because some kids are just maturing faster than others? Or is it language specific? Is it to do with the amount of input their parents say? We do have massive differences in input. We have LENA data, and some of our kids hear about 7,000 or 8,000 utterances a day on the LENA, and others hear like 20,000 utterances a day. So we can certainly definitely look at the role of the input in both the role of the input and non-linguistic cognitive abilities in these relationships. In one of the millions of papers that I was talking about, we still have to come.
Okay, another question from Michael Israel, and I've got to ask this one. Are writing system tools or toolkits that make or arose through the use of pre-literate language? Lots of evidence shows that literacy radically restructures brains.
Yes, I mean, yes. My children, we followed them till 4.5, but Kate Kane at Lancaster University is following them into school. Unfortunately, that's been affected by COVID, but we will hopefully have measures, at least sort of standardized tests of their particularly their literacy ability as they move into school. And we were thinking about that in terms of, can we predict their later literacy from their earlier language? But I guess we could also, it'd be also interested to see how the literacy affects their language ability and in what way. There is this weird relationship that there's no you can't predict which children will have. It's really hard to predict which children will have developmental language disorder or dyslexia from sort of vocabulary at age 2, before the age of about 3.5. So there's no continuity between early language and later language, or early language and literacy. So there are clearly qualitative changes happening over the first 5 to 6 years of life that could well be affected by literacy. But yeah, it's not a simple linear relationship between early language and later language or later literacy.
You probably have to look at later language, not 6 or 7 or even 8-year-olds. There is research on this suggesting that it's actually about 4 or 5 years of literacy when it begins to make a difference.
Great.
Okay, so there's a question that was asked but seems to have got lost. This is from Karen. I can't read the name. Anyway, what do you think are the innate constraints of language learning? You said we could ask the question period.
Okay, Ava, you're breaking up a little bit for me. Hopefully not for everyone else.
Okay,
But I got the question.
Constraints.
I got the question. There are perceptual constraints on learning, and that's all I'm willing to say. We as a field have tended to distinguish between linguistic knowledge and innate cognitive constraints. And so we tend to maybe hand wave about building in what are actually quite sophisticated higher order abilities, like distinguishing between agent and patient roles, or even just distinguishing between participants in an event, or understanding, so I think that we have maybe in our field, because a lot of us are fighting against this UG, we've tended to hand wave a little bit too much about what are quite sophisticated higher order cognitive constraints. So let's take the 9-month revolution, right? The referential intent comes in. Children start to understand referential intent of the speakers at around 9 months of age, and that does seem to have an effect on how quickly they learn words. But that development of referential intent understanding has like a massively long history, right, in the first 9 months of life. So is that an innate ability, that an innate constraint that comes online at 9 months of age, or more plausibly has that built up sort of slowly as we're learning more about communicative partners? So all I'm willing to say is that there are definitely perceptual constraints, and I think we need to look harder, not just at arguing or looking for innate linguistic constraints, but really considering whether there are higher order cognitive constraints in how we perceive the world and relationships in the world, or whether all of these are learned.
Okay, one last question, then I think we'll have to break up from the Q&A. Great talk and very reasonable, but has anyone checked test retest reliability or statistical learning sort?
Say that again, I missed that, sorry.
Has anyone checked the test retest ability of statistical learning?
Yes, we haven't of these statistical learning abilities. I'm quite nervous about them because we did the causality study that we did, we found really low test retest ability, and this is a big issue, right? How we use these tests to look for individual differences and whether they're actually reliable or whether we're really only getting at noise. I have I think it's like a 48-page Google Doc at the moment on problems, how to interpret looking time measures. And I think that we've got a lot of noise in our data. So kind of if you find a relationship, it's amazing, but we definitely need better measures. I know that there's been some work on showing that statistical learning is not reliable, but actually I have colleagues who argue that actually there are tests and you can find reliable, valid individual differences in statistical learning ability. So we just need a lot more work on the psychometric properties of our tests. And
what would be the more reliable ones?
Pardon?
What would be the more reliable statistical learning measures?
I don't have any in my head to say these ones are reliable or these ones aren't, but I know that there is not a complete consensus that they're unreliable, and we don't know, right? We just need lots and lots more work on the psychometric properties of statistical learning tests and to figure out which ones make them more or less reliable. It's not reliable versus unreliable, it's kind of signal to noise ratios. So yeah, we are always fighting against the noise in our data. But I'm generally happy if I find any relationship or if I find group effects. I think it's important to find group effects as well as individual differences.
Okay. Okay. Well, thank you very much, Caroline. I will ask you a lot of questions. Thank you very much for a fantastic talk. If you have a quick look at the chat in the Zoom seminar, you'll see a lot of very, very positive feedback. So before we take off, we have in a minute sort of meet the team session in the break. Berda, would you like to say anything about it?
No, that's okay.
That's okay. Okay. People, if anyone wants to join us, you can find us. Thank you very much again, and a big round of applause.
Just quickly for people who didn't hear, because Ewa, you were breaking up a little bit, just wanted to say that we have a virtual meet and greet with the organizing committee and some of our plenary speakers in the break. See you then.